Hi, I have a very interesting guest today, Mr. Sanjeev Rotkar. He was the former uh, executive director of aviation and engineering at Air India. I think you've been associated for the past 43 years. You're semi-retired now. And if I start beginning to read what all you have achieved, I think pura podcast hi usme jayega. So, welcome to the podcast and thanks for making it here. It really means a lot. So, I want to start with, before I start with all the big questions, what does actual aviation engineering actually mean at scale, at any aviation industry? Mostly people knows aviation matlab pilots, the ground crew,
they see.
Yeah, what they see, the queues and all those things. But you people work in the back end, you're not visible, and I think pilots usually rely on people like you. I mean, unless and until you guys don't give a go ahead, they're not flying.
Right.
So what actually happens, and why should people be interested to hear and listen from a person like you? कि hangar के पीछे क्या हो रहा है वो inside?
Okay, good question.
Yeah.
But before that, Sameer, thank you for inviting
Thank
me. I've been following your channels for quite some time now, and I'm quite impressed. And you cover a variety of subjects,
Right.
and make it entertaining and informative.
Thank you so much.
Which is so nice to see. And I particularly like your aviator look today.
Yeah, I purposely wore it because बोला कहीं पहनने को मिलता नहीं.
So there is a saying in aviation that once a aviator, always a aviator.
Oh, lovely.
So hopefully all your life now you will carry on this tag of being an aviator.
But I'll tell you, this is 8 years old, and then still serving its purpose.
Oh, so you are a veteran aviator now. Good. So,
Nice.
okay. So, Sameer, to answer your question, engineering is the backbone of aviation. And I'll take some time to answer this question because, we should understand what engineering is to aviation, then
Right.
understand what engineering is to airline.
Right.
They're two different things. So, let's go back in time.
Mm-hmm.
Early man,
Yeah.
and when I say man, I am gender neutral,
Yeah.
so consider
Yeah.
it as a person. So he was fascinated by birds flying. So he strapped wings on his back and dived from a mountain or a cliff or something,
Right,
only
right.
to crash land.
Obviously.
And then he realized that human body
Is not meant
is
for
not
flying.
fit for flying.
Yeah.
It's structurally unsuitable and too heavy.
Right.
From that time to here, today, you see aircraft flying at 500 kilometers per hour at pressures and temperatures where no human being can survive.
Obviously. I mean,
And still land at a safety record which is better than traveling on a highway.
Yeah.
That is an engineering miracle.
obviously.
You know.
We have supersonic aircraft as
Yeah.
well, obviously.
So you're dealing with the absolutely state-of-the-art, cutting-edge technology in aviation. And you see, it starts with materials. The kind of materials which you see on your ground vehicles, cars and rails, are not used in aviation.
Right.
We use very advanced superalloys and composites. Then everything, right from the first sketch to the last bolt,
Right.
safety is engineered into every single aspect of aviation.
Mhm.
There's so much of emphasis on safety. Then there are redundancies and backups. Every system has a redundancy, has a backup.
Right.
And there's an interesting thing called Murphy proof, Murphy law. You know what is Murphy law? Murphy law says that if things have to go bad,
They will
at
go
some
bad.
they will go bad.
Obviously.
So supposing you make a right-hand component and a left-hand component similar, interchangeable, it's bound to go wrong. Somewhere down the line, mechanic is
right.
going to make a mistake. So every component is made Murphy proof.
Okay.
So if this component, left-hand component has got a tab on the left side, this one has got a tab on the right side. So they can't interchange unless they're
Right.
meant to be interchanged.
Obviously.
So whole lot of thought process, whole lot of sophistication goes in engineering.
Mm-hmm.
So what it means for the airline? This is the backbone, as I said, for the airline. It is an invisible system which sits on the entire aviation ecosystem, airline ecosystem. And it starts, surprisingly, well before even the aircraft joins the fleet. When the decision or the discussion on acquisition of the fleet starts, the engineering department, the performance engineering, or whatever you call it, each airline calls it differently, they get involved in the selection process.
Oh.
So unless you select the right model of the aircraft,
Right.
you won't get the right aircraft. All aircraft are good, But maybe your need is not for a wide body, for
Absolutely.
a small, narrow body or even a turboprop.
Right.
So unless you know the dynamics of that aircraft, the performance of the aircraft, how it performs in real life condition where you're going to operate, it is meaningless. So it gets involved from there, that stage. And then comes all the customization of interiors, your choice of avionics, your choice of so many components. So it starts much before even the aircraft joins the fleet.
Right.
Then there are planning of maintenance bases, so recruitment of qualified manpower, appointment of key personnel. So this is something which happens much before, even before the aircraft joins.
So nice.
And then when the aircraft comes, the real action starts. The job of an engineer is to keep the aircraft flyworthy at all times. You got the state-of-the-art aircraft, but your job now is to maintain it in the same condition throughout its life. So that is the core job.
Right.
But it is not as simple as it looks because it involves so many things. There are so many components in aircraft, the hydraulics, avionics, the whole lot of departments like procurement, there is logistics, there is quality control, there is continued airworthiness. So all those things are put in place to make the aircraft flyworthy. And remember, there is no breakdown maintenance in aviation.
What does that mean?
Like if you're operating a machine tool or a machine in a factory, if it goes bad, you can always repair
it, right.
But in the flight, you
it's
have
not
no
possible.
way of repairing the aircraft.
Right.
So it's always preventive maintenance.
Right.
We don't even call it preventive today. It's predictive maintenance.
Okay.
We predict what is going to happen and take appropriate action before it happens.
My goodness.
So that is the level of sophistication we do, and so we are one step ahead of whatever is happening.
Right.
That is the function of a key engineering department.
I can draw a parallel here as a doctor. Medicine is nowadays going towards preventive medicine. कि आपको BP वगैरह है, get an echo done, get this done. If you have something, इसको अभी ठीक कर दो, let it not grow. So that's like a same thing that's happening in medicine.
Absolutely.
Predictive maintenance and same thing.
Yeah.
So nice.
So, and then, where was I? So basically it's predictive maintenance. I would like to, emphasize on one important thing, which might sound interesting.
Go for it.
Normally when we look at engineering, we talk of machine, hydraulics, avionics, this, that, But there is some important aspect of engineering called human factor engineering. Every engineer, every pilot, every cabin crew undergoes a regular human practice course, refresher course or main course regularly, every year or something.
Right.
Now what it deals with is how humans interact with machine in complex environment.
Very true.
You may be having a night shift. Your energies are all at the lowest level,
right.
But still you have to do the task with utmost precision. There's a whole lot of noise happening, the vehicle is coming, you're going, hundreds of things, but you have to concentrate. So how to interact in those complex environment is taught in human factor engineering. And they are trained.
Obviously.
They are trained in this to focus, to how to communicate, how to concentrate. So and this is done every year. It's not a one time. There are so many complex industries in nuclear plant and so on, but this kind of thing is not seen.
No.
Whereas aviation practices it and practices it regularly. That is the difference, and that is part of engineering also.
It's a well-oiled machinery. Every cog is working in its own place.
So as I said, it is sophistication of some different level.
Obviously. So airworthiness, that's a term we get to see. It's thrown around a lot. What does it really mean in practice?
So as I said, I know you got the state-of-the-art aircraft. Your job is to keep it at the same level, flyworthy at all times, so that it's doing the job of flying.
Right.
And flying is a precision job, so you have to keep it flying. That is basically the meaning of airworthiness. That at any point of time, when it is out of maintenance, it should be airworthy. Now this has got a complete system behind it. It's not when I wish it happens. It's not like that. So what it does, what it means is there are various things that happen. There are regular tasks which you have to do. For example, there are inspection schedules, daily, weekly, monthly. those inspection schedules have to be complied. Then there are certain manufacturers issue certain service bulletins to improve the reliability, to improve certain conditions of certain operations, maybe specific to area, maybe specific to the aircraft. And sometimes they become mandatory. So they are called airworthiness directive. So all the airworthiness directives have to be complied, and there are so many components on the aircraft. Each may have certain controls, like some may have life limitation, some may have some other inspection call outs. All those things have to be complied well in advance and in the allotted time, because you're not buying an aircraft to keep on ground.
Right.
So you have to comply it, plan it, comply it in such a way that you finish it off in a minimum possible time. And keep the aircraft flying. That is the meaning of continued airworthiness, and that's the meaning of making it airworthy at all times.
But I'm thinking there must be instances in terms of engineering when there is no perfect answer, but the aircraft has to fly. So you take some mitigated risks, and there is no perfect solution happening, and somebody has to sign off on the risk. How does that look like? Have you been in such a position ever? What happens then?
Okay, I'll tell you with something like a real life example.
Sure.
So, to step back, aviation safety is binary.
Okay.
Aircraft is either safe or unsafe.
Unsafe, right.
Whether I like the aircraft to fly or not. If it is not flyable, it is not flyable.
Okay.
There is no such thing as releasing half airworthy aircraft.
Right.
It doesn't happen.
Okay.
But there are certain real life incidences
Obviously,
where I have to take a decision. I'll tell you a simple decision would be like aircraft has been sitting in ground for 6 months, for whatever reasons, hundreds of reasons. And now it has to be moved to a facility, we call it MRO, Maintenance Repair Organization, which is say 5-6 hours away, Obviously something has to be done. I mean, even if I have to put that aircraft back in service, it needs to fly there.
Obviously.
So this is a real life situation where now what do I do?
Barabar.
I have a unserviceable aircraft sitting on ground. So many things have happened over 6 months, but I need to fly it to somewhere to get it into a shape.
Right.
So what I do as an airline person is that I comply whatever is basically required, as if it was in service. What was required, I comply that. Then I approach the OEM, the original equipment manufacturer, that look, this is my condition. I need to fly this aircraft, and it needs to go. So then he'll ask me, well, have you done this inspection? Have you, changed all the life expired items? Have you performed this ground run? Blah, blah, blah. So I answered all these questions. And then he does a risk mitigation analysis, because he is monitoring aircraft all over the fleet.
Right.
He's all aircraft are monitored these days. So
Right.
he has got lots and lots of data. So he does the risk mitigation, and then comes out with some solution that, look, okay, I'll allow you 5 hours, but I'll have 2-3 restrictions. So the restrictions being, it can make only 2 landings or 3 landings.
Okay.
So I can't allow a 4th landing.
Oh.
Or he may put another condition that it is a very kind of deteriorated flight. So landing gears need to be down at all times.
Obviously.
So some kind of conditions.
Right.
Or he will say that, look, I'll allow only if you perform some ground run.
Right.
And then say that this ground run parameters are okay. So that mitigation is done by the OEM. Now it doesn't end there. With this, I approach the regulators. And I approach the regulator with a permission for a ferry flight for 5 hours based on the restriction recommended by the OEM.
Is that the DGCA?
In our case, in Indian case, it is DGCA. In the American case, it's
Obviously.
FAA, European is
right.
EASA. And mind you, FAA, EASA, when they give approvals, they are world-class regulators. I mean, if you see the standard of regulation, it is absolutely top class. So they do the final analysis and they give the permission. So the risk it's not one man signing, taking a gamble.
It's multiple people at different levels.
It is a risk mitigation over layers and layers of
Obviously.
processes.
So nice. So, I mean, क्या प्रेशर होता रहेगा at certain point of times, you know? I mean, if somebody is telling you कि 2-3 लैंडिंग में ही you have to send to MRO. I mean, what if it doesn't make the, I mean,
Such conditions happen. Normally, if supposing we have this 5-hour flight, let's say, and then it can be done with one.
Right.
Normally, would ask for 2 landings because in case there's a diversion, if we encounter some bad weather, you know, and you have to land somewhere, I should have at least one cycle in hand to reach the
Obviously.
destination. But yeah, there have been cases where aircraft got stuck in some, you know, unwanted, so to say.
but does that, so sorry, but sorry.
Then the whole process is repeated.
Does that happen कि an aircraft like this is going for maintenance to an MRO, so they fly different routes than normal aircrafts to avoid some unknown?
No, they won't fly different
Out at
route.
different altitude, maybe?
No, they won't fly different route. But in certain cases, when you file a flight plan, these things are disclosed to the traffic controllers.
Okay.
That look, this is a ferry flight. This is going at
Nice.
this thing. This has got restriction on the altitude or whatever.
Right. So Air India was famous or infamous, I don't know what to call. At a point of time, it was running a very old fleet of aircrafts. You were the engineer who was responsible to making it kept flying. So what does it feel like to manage a fleet of aircraft that has aged beyond its design life cycle?
Well, there is no such thing as designed life for an aircraft.
Okay.
A well-maintained aircraft is airworthy as long as it is certified as airworthy after meeting all the criteria.
Okay.
Since you asked this pointed question, let me explain like this. There are so many concepts, in aviation engineering, airline engineering. There is some concept of continued airworthiness. You have to maintain aircraft in a continuous airworthiness standards, which in turn requires so many other things. Carrying out schedules as per the maintenance program, carrying out certain structural inspections, carrying out certain service bulletins, carrying out certain alert service bulletins. Then there is a concept called hard life and soft life. Hard life means a particular component has to be retired at that particular time, at that particular hour cycles, whatever. So even that means removing of that higher assembly off ground and taking it to the shop, it has to be done.
Right.
So that hard life component is replaced with a different component which has got better life, and then that component is good to go.
Right.
Now, what happens during the process? There is something called soft life. So that is called an opportunity inspection. That when you're maintaining the component and taking care of the hard life, there are certain components which may look not so good.
Dicey, okay.
Yeah, they may not give problem now, but it is better to do it.
Yeah,
so that is soft life. So we take care of the soft life also in that. That is a very opportunistic way.
Right.
So combination of all this, continued airworthiness, continuous inspections, continuous monitoring of safety, records. Records is also very important. We'll talk about it later sometime. Record keeping, all the service bulletins, the standards. Then there is something for aging fleet. There's something called corrosion prevention programs. There's fatigue management program. There is something called life management enhancement programs. When you do all this, aircraft is as young as it was.
So normally, what is a life of a...
I'll give you 2 examples. Let's take Delta, which is one of the biggest,
sure.
and take United.
Yeah.
They are still flying Boeing 757s.
How old are they?
They must be like 30, 35 years old.
My God.
And they're flying. I mean,
Domestic or international as well?
Domestic. They do hub to hub.
Right.
They find it suitable hub.
Right.
So they have advanced. They have marveled their engineering, or they tailor-made their engineering to such an extent that they are expert in managing that fleet.
But since you brought up these 2 names, Ryan Airlines is supposedly the cheapest, is what I've heard. How are they managing?
So that's a different model. The LCCs have a different model than the legacy. Their management goes into operating a younger fleet. So then we're going to go into the cost economics.
Okay.
We don't go into the airworthiness.
Right.
I will talk of that model, LCC model, later. So let's finish this. So there are airlines operating this kind of thing.
Right.
Then there are cargo operators, like for example FedEx. FedEx operates MD-11. MD-11 were flying, McDonnell MD-11 was flying in 80s.
Obviously.
But the cargo operators find it suitable because it is structurally a very strong aircraft, which is ideal for cargo, and it has got long range.
Right.
So why not fly it? Then I'll give you an interesting example. There is something called BT-67. BT-67 is reincarnation of Dakota DC-3.
Okay.
Dakota the DC-3 flew in World War II time.
My God. 40s.
Yeah, and there's some interesting movie, The Longest Day.
Oh yeah, I know. I remember that.
It featured Dakota DC-3 where the paratrooping, paratroopers are dropped over Normandy. So it is a very legacy aircraft.
Right.
But today, what they have done is they have retained the form of that aircraft. They have changed the engines, they have modernized the avionics and everything, but retained the basic form. And it's now called Bachelor BT-67. And that's the mainstay of Antarctica logistics. No other aircraft can operate there.
So the fuselage is the same. More or less.
Fuselage shape, at least you can say, is in the same. And that entire Antarctica logistics, in that freezing condition,
My God.
is taken care by BT-67. So there is no such thing as old aircraft. It is how you manage the fleet.
But then you talked about Antarctica. Do they put a little bit of antifreeze in the fuel?
Oh yeah.
Obviously,
they may be taking all that precaution. Yeah,
And
that of course. I mean, if you have to operate in that, you have to do that.
But the antifreeze of a car would be very different from an antifreeze of a aircraft. I'm guessing.
Yeah, not only in the fuel, the whole lot of things you have to de-ice the control surfaces, because if the control surfaces are jammed,
Right.
the repercussions are quite obvious. So yeah, there are precautions to be taken.
So nowadays we see in India a lot of I think Indigo is a major player now. Even the rest of the players are now moving to a leasing model. We are not buying aircraft, we're just leasing them out. What does that look like from an engineering executive point of view? Is it a nightmare, or have things become easier? Has the liability increased or decreased? What happens?
So, to answer it in one sentence, it is a mindset change.
Okay.
Basically, what happens here is when you go into the leasing module, the asset is not yours. The asset belongs to the lessor, and it is given to the airline for a limited period of time for operation. So, let's say you are transiting from a own fleet to a completely leased fleet. You are used to certain culture. That
Obviously.
the aircraft is your tool for operation. But lessor doesn't see it as his tool of operation. For him, it's a financial asset where he has to protect the financial asset value of that equipment. So for him and for you, there are two divergent things. For you, it is for you means the airline, it is a tool of operation, and for us, lessor,
it's an asset.
it is the asset value which he has to preserve. So many things develop in this. You have to come to some common ground. So what happens is, in the normal ownership model, you would normally restrict yourself to satisfying the regulatory conditions. But now you have a lease document, lease agreement. You have to satisfy that also. Generally, in certain aspects, the lease documentation and contract is stricter than this for a particular financial value.
Obviously.
That you have to carry out certain tests or tasks, even if it is not due.
Absolutely.
For example, at redelivery, you may have to paint the aircraft. In normal circumstances, you may not have needed to paint the aircraft, but now you are returning the aircraft. Lessor doesn't want in your livery.
He wants as is.
He wants it in a particular livery of his style. Right. So you have to comply that. Then he wants probably a complete refurbishment of the interiors, because he doesn't want your legacy to remain with the new lessee. So all those things will have to be complied. So it's a mindset change.
Right.
What it means actually for operator, it becomes his books of account become very light. It goes as a lease thing, as a rental thing for him. The ownership thing, then again the depreciation and all that thing comes up. So his balance sheet becomes lighter.
But from a engineering point of view, has the dependency created a new problem that nobody was prepared for?
I wouldn't say it has created problem. It has created some additional work and headache load. Let's concede that you have to comply with certain, more tasks and more. Maybe I'll tell you an example. Maybe you are used to keeping records, your engineering records in certain way. Now lesser will come and say, okay, your engineering fine. I mean, I records okay, but I want in my format.
Oh.
I mean, obviously, because there are so many ERP systems. You are maintaining as per a particular ERP system, but he says, no, this is too tedious for me. I want it slightly reformatted. So, you have to comply.
Obviously. Oh, nice. So, let's talk about power by the hour contracts. I think you were one of those few people who understood power by the hour contracts deeply enough to negotiate them and to understand where they trap you in such contracts. So first of all, for people who are watching this, please explain what are power by the hour contracts, and then we'll move on.
Okay. So, when we're dealing with pure legacy airlines, the legacy systems, like say of 70s and 80s, the power by hour thing was unheard of. This concept started picking up somewhere in late 80s. Then in 90s, it kind of became more offerable. And by late 90s, people were just loving this product. So what is it? Power by hour generally is applicable to some components for off-wing maintenance. Let's say engine, for example. So when the engine goes for maintenance, its repair cost is too high. We are talking of a bill of 3 million, 4 million. And in aviation, we always talk dollars. We never talk of any other currency. We are talking of huge outflow. And especially for low-cost airlines, to pull that kind of money out from, as it is, it's a thin margin business, to kind of make provision becomes difficult. And also you are exposed to risk. Obviously. Because anything goes wrong in that machine or that engine, you have to fix it.
Exactly.
So then came this concept of power by hour. So OEMs came to the airlines and said, look, we'll offer you a product wherein you have to pay us a monthly fee or let's say a remuneration,
a subscription
kind of a thing. And when the component, the engine goes to the shop, we will take care of the maintenance.
Oh, okay.
So instead of staring at a big bucket figure 4 years down the line, you are making a structured payment.
Right.
And then the various models evolved that in certain cases, you don't really pay the money. You pay certain small lump sum and then pay at the event. But that money, you are blocking that money with you somewhere. So that is a very predictive thing for you. That is the main advantage of power by hour. The second advantage is that it's a risk sharing. It is like buying a medical insurance. Same thing happens in medical insurance. Instead of footing a bill for a knee replacement surgery or cataract surgery or whatever, you are paying it chota amount every month. And then when the event comes, you get reimbursed.
I'll give you a better parallel. Most of the machines that we work with are very costly nowadays. Cataract machines, MRIs, all these they're costing over 1 crore, single machine. And every doctor has 2 to 3 such machines. So we have something called as a comprehensive maintenance contracts with the company. So certain amount we pay annually or every quarterly, we just whatever we decide contract with the company. If anything goes wrong, the component, I don't have to pay a single rupee for it. An executive will come, he'll do what needs to be done, and I'll have my machine working again. There is something called as annual maintenance contract. Isme, the parts are not guaranteed. You will have to pay for the component, whatever goes down. It's quite similar to what you're saying, power by hour contracts. So, nice.
Yeah, I mean...
But where do they trap you?
It is more or less the same.
Yeah.
I mean, there are different names, but probably the underlying concept is the same.
Right.
But here the difference in power by hour is you get a guarantee of a improved product. Upgraded, improved product.
Right.
If it is there in the contract.
Right.
So you get that advantage. The second thing is, one of the drawback of power by hour, as I would say, or rather, I don't know what to say, but let's say drawback for simplicity. You lose certain freedom. The airline loses certain freedom.
How so?
Because if you are managing the fleet by yourself, you have a lot of freedom. You say that I'll remove this engine after my peak hour schedule is over.
Right.
But once you are in PBH, the engine manufacturer or the service provider might say, look, no, your engine is deteriorating too fast. Now if you make it run for another 2 more months, I'll have to incur that extra cost. I'm not going to do it.
Right.
So I want this engine to be removed now.
Okay.
I'm just giving an exaggerated example.
Yeah.
It may not be. Then in your if you are not in PBH, or you again, I make the same mistake. If airline was not in PBH, probably they could have sent their engine somewhere else. Any different MRO. But OEM, here with the service, you are bound by the service provider.
Yeah.
He will say, you send this engine here, you have to send the engine there.
There's no third party.
There's no freedom.
Obviously.
And then the third is the work scope. What extent of work can be done? In earlier case, you are the owner, that you want a small job to be done, a big job to be done, depending on your requirement. But here the OEM will have the say that, look, I will perform this work scope for you.
So does it ever happen that unnecessarily you are given instructions to change certain OEM components and just to increase the billings?
In this kind of thing, let's keep it. I mean, if let's say it's like you're giving your car to a garage.
Unnecessarily, say filter badal do, ye badal do.
So that things can happen, right. But I don't believe if you because now we are dealing with professional engineers from both sides. People understand the business,
right?
And what happens in such major shop visit is you get involved in each and every component replacement decisions. So it's mitigated to a large extent, but yeah, I mean that possibility exists. But let me conclude this PBH by saying one more thing. As I said, it evolved over a period of time. It peaked. Surprisingly, now certain OEMs are shying away from offering PBH.
Why is that change happening?
So now they have realized they are exposed to too much of risk. If engines are having some design problems, or they are operating in harsh environment conditions, like in India is called a harsh environment.
Why?
Our environment is harsh. We have a lot of sulfur in the atmosphere, which is an enemy of engine. We have a lot of pollution. We have very high ambient temperatures. So all this is not good for engine health. So India is classified as a harsh environment operator.
Okay.
And OEMs have realized that in harsher environment, the engines don't perform so well.
Obviously.
Already they have given you a guarantee that you pay only this much. But if the engine comes out early, they are getting exposed.
Can't they increase the subscription cost?
I mean, once you are in contract, then...
True.
So what they say, no, they're too much of problem. We'll give it only to niche players like big players. But normally now they are shying away from giving it to smaller players.
Okay.
Second thing, what happens here, when you go to OEM, the earlier case, I'm kind of jumping back and forth. I should have said this earlier. The very idea why PBH was offered by OEMs earlier, they wanted to protect the aftermarket completely. In 80s and 90s, what was happening was people were making independent decisions. They would send their equipment to any independent MRO. They'll use non-OEM materials.
Right.
So they wanted to control that. Now, the thing, wheel has turned a full circles. Now, OEMs are getting cautious. Look, okay, we'll give a PBH only to certain players. Other players, no.
So
we'll bound you by some other way.
So high risk zones where PBH is not so fancy for them in nowadays.
I mean, it's now a kind of from an ultimate monopoly, it has turned to be a little bit more flexible. That, we'll give PBH to certain operators. We'll cover the other operator.
Yeah.
We are not saying, OEMs will say, we are not covering the other operator. We are not leaving them in lurch. But not through PBH. We'll cover them through some other
means. Yeah, very true. While I was researching all these things, I came across a term called as AOG, aircraft on ground. And I've understood that this thing sends a controlled panic throughout the hierarchy. Why does that happen? And walk us through the first 24 hours of AOG.
Okay. AOG is aircraft on ground.
Yeah.
In short, it means a very kind of a unplanned grounding of aircraft, which should not have happened, which no airlines like. You know, if your aircraft is grounded somewhere in Timbuktu, a whole lot of logistics. So, but it happens. So, there are certain problems. There could be a bird strike, for example. It has, screwed up the engine. Then you need to do something. You need to mitigate, or there is an avionics snag, or there is a component failure, or there is some pilot reported issue which needs to be solved. So, whole lot of events are triggered by that. So the first and foremost is, for example, a simple thing like, for example, aircraft encountered a fire detector warning. So simplest thing would be, engineer there at the ground would say, I require time, I need to open up and check what is the issue. And then for that, your scheduled flight, which was just 30 minutes after landing, can't happen. So that is AOG,
right,
in short. So he'll say, I'll require 2 hours to operate. He says that, but it triggers a lot of back-end action. So somebody, even before this engineer has made this decision, as I said, the aircraft are throwing data. Every time it is flying, it is throwing data. Somebody has already picked up that fire warning thing and started working.
Okay.
So
somebody
said,
as in who?
There is something
the
called
controller?
The maintenance control.
Okay.
We call it MCC, OCC. There are a whole lot of operation control, maintenance control, Mentrol. So many control centers all over the airline network have picked up that signal.
Okay.
And they have started working.
Okay.
And so they will go by the back history, like in the past, if such problems have come, what was the best rectification. Then they would see that whether the spares are available at that station. So all that back end, if not, they have already started making arrangements to ship the spares. It may be, maybe engineer would fix the problem by a loose nut or something. The problem can be fixed, but they are taking action from their side. So it's not a one-man thing.
Yeah, obviously.
So and then the commercial operations, they are involved. They are rescheduling the flight, because if the flight is now getting, say, grounded for longer time, there is something called flight duty time limitation for pilots and crew, so they have to position new set of crew.
We had that fiasco beach mein, same thing because of this.
So whole lot of things happen. So everybody gets triggered into action. Everybody has got a task charted out, and he is doing that.
Right.
So whole lot of events, whole lot of chain. It triggers a chain of things.
So let's say there's a minor glitch and the engineer says ki in 2 hours I can make this aircraft airworthy once again. So let's say एक bolt ही कसना था. Then does it go to the MCC and all those people that now this is okay, or it's just reliant on the engineer on ground to just say कि हो गया तो हो गया?
No. See, the entire certification process is carried out.
Okay.
Means he would first see, first of all, anything in aviation is found out, documented, rectified and certified.
In multi-layered format is what I mean.
Multi-layered format.
Yeah.
There's no such thing as just tightening a screw and let it go. He has to record his observation, what he observed. He has to record what action he has done. He has to sign it off and then sign the aircraft off. So it's a layered thing. It's not just, even if he manages to just tighten a screw or bolt or whatever, it's not that small action. It has to be a documented action with a certification. So that certification has to be done. He has to certify that, go to the cockpit and check whether now that fire warning has stopped or not. And then he can declare the aircraft serviceable. Maybe he has to perform a ground run also. Who knows? Right. So he has to do all that and then certify. So it's not like one man just doing whims and fancy. It's a layered, calibrated process.
But recently I was reading that bird hits are no longer a reason for them landing back on ground, or because of the technological advancement, or is that still not foolproof enough?
That's true. See, what happens is the design of what happens in bird ingestion is like your it's like hitting somebody with a bullet.
Hmm.
When the aircraft is traveling at that speed, when the bird strikes, it is like a bullet
Bullet.
hitting the
Obviously.
aircraft engine or whatever, aircraft control surfaces or radar or whatever. And it creates problems. Now, when you probably the report which you read, there are a whole lot of things which have gone into the engineering aspect. The radomes, for example, the nose of the aircraft is called the radome. They are made of soft material. So it kind of absorbs but doesn't shatter. So maybe you just change the radome and then, nothing inside that gets damaged. Or you see the blades of the engine. Next critical point is the birds normally get ingested into the engine. Engine is the front part of the engine is the engine fan blades.
Yeah.
And the contour of the fan blade is such that it is thrown out centrifugally.
Oh, yeah.
It doesn't get ingested in the core of the engine.
Okay.
So the downstream damage is prevented. But if the blade is damaged, you have to declare AOG and replace that blade. The damage control is definitely there. You are not going to change the whole engine. But you may be required to change the blade, or you may be required to blend a blade. You may be required some minor repair or in situ repair. So depends.
So, in terms of stakeholders, when an aircraft is grounded, everybody's looking for answers. And unfortunately, I don't know, I feel in a city like India, everybody is looking to point fingers. Ki teri wajah se, teri wajah se. Is that really happens, or it's a very professional environment that we see happening over there?
In my opinion, when you are performing tasks under high media pressure, high public scrutiny, leadership has to rise higher.
Right.
If the leadership falls back on cutting short, instead of making what leadership should do is to strengthen the decision making chain.
Right.
So the decision making is faster and more robust. But if you adopt a shortcut practice, that look, I am under severe pressure, media is following this, let us take a shortcut, let us do this. Invariably, that leads to more failure.
Okay.
That is my assessment of the whole thing. You may have to hasten up certain processes, you may have to chase certain things, but on the whole, as a leadership, your responsibility is to make the decision chain stronger, robust, and more adaptive.
We had that very sad incident in Ahmedabad, a flight, I think it was flying to London. What do you think from your perspective? What was the single chain of events that happened at that point of time?
So I'll club this along with aviation safety. I think instead of one incident, as I said, aviation is the safest mode of transport today. And let's take statistics of 2023. 37 million flights and not a single fatal accident. There is a saying that, why saying? There is a statistical model. If a flyer has to fly and meet with a fatal accident, he has to fly for 100,000 years continuously. So that's why they say a frequent flyer is more likely to meet with a highway accident rather than a airborne accident.
Right.
So aviation is by and large very safe. And it is safe because of various reasons I explained. The safety is inbuilt in the whole thing, right from the first bolt to final. But there is something called a Swiss cheese model. Swiss cheese is what? A slice of Swiss cheese, it has got holes, right? And if you keep a slice of cheese and then under that another slice of cheese, under that another slice of cheese, the holes are not likely to align. So if you drop a pin, it may pass through one hole, but it will get stuck in the second layer, third layer, somewhere.
Yeah.
It's very rare that the pin will fall through the whole, the entire set of holes.
Statistically possible, but the probability is
very rare.
Yeah.
But such things happen. What happened 2 weeks back in New York, LaGuardia?
Yeah.
There was an emergency declared by United Airplane. A fire truck was dispatched. And the controller, there was a single controller who was operating the whole thing. He was under tremendous pressure. And he told the fire truck to proceed. The fire truck stopped. There were two runways, two parallel runways. The emergency was on the second runway.
Right.
And the fire truck wanted permission to cross this first active runway. So the fire truck asked permission to cross. He gave the permission initially. Then he realized that he has already given a permission to Canada Express plane to land. He's overworked, see?
Yeah.
So he shouted at that truck, stop, stop, stop.
It was too late.
But see now what? This is the Swiss cheese theory. He shouted, not that he didn't do. He did his job. But the aircraft was coming from his right side. And this driver was on the left. He couldn't see the aircraft coming.
Right.
And because he was asked to go on emergency, you know, when a fire truck goes, he goes on an emergency always. He is not, cushy, listening to music and, he's not in a relaxed state of mind. So he is rushing there. So he didn't hear this controller shouting to stop, So such things happen, there are layers which somehow break. But talking about this case, Air India case, there is something called a Dunning-Kruger effect in psychology.
I know about it.
They are told 10% of the fact. And, especially social media is very,
In Marathi, we say "Ajnanat Sukha hai." That is basically Dunning-Kruger effect.
So, what it does is you are given 10% of the fact.
Yeah.
Your brain manufactures 90% of the story and believes that is true.
Obviously.
See, after Air India crash, everybody became a RAM expert. Every Indian
exactly
was talking of RAM. I mean, very few in aviation probably understood what is RAM and what is the purpose. But every Indian thought that he is the RAM expert. But now, accidents it should not happen. This was a sad case and it shouldn't have happened at all. And what is perplexing is that after the crash, the group head of the biggest conglomerate in India is holding meetings with minister and talking of minimum equipment list.
Oh.
Now, minimum equipment list is something which aircraft is allowed to fly with certain deficiency. Now, this is a very small engineering function. I mean, it needs to be done at an engineering process level. But if it is getting discussed at that level, that means there is some slippage in the safety.
Right.
I mean, I'm not saying the aircraft was unsafe or something terrible happened there. I don't say that. But the fact is this discussion is happening at that level means certain less than robust processes are existing down the line somewhere.
Okay. So was it, do you mean to say that was human error?
I wouldn't say that. The inquiry is still going on.
Okay.
There are speculation at this stage, a lot of speculation, but let the inquiry happen. They have inspected something like, I think 1400 switches in this particular case. They have not found a single switch defective. So that gives me a reason to believe that aircraft is inherently safe. But what happened that day and what triggered it, at this stage, let's
still
not
unknown.
put any I mean, there is no point in speculation.
I know. Let's talk about OEMs. I mean, you have sat across tables from Boeing, Airbus, and GE, and Pratt and Whitney. How does an OEM negotiation look like?
Okay, good question. See, when you are dealing with OEM are big companies. They are giants. So it's like facing a mountain. But remember, they respect customers. All OEMs respect customers. The knack lies in feeding them the correct information.
Okay.
Not, hurting their egos, not hurting them below the belt, but going with facts and figures. That look, I am facing this problem. My aircraft is not having the reliability that it should have because of this issue. You should go with facts and figures. They respect facts and figures. And as long as you keep this kind of topic at professional level, you should be clear in the support you are seeking. You can't say you are bad. I mean, what's the point? He is the OEM. He has given you the product. You are operating the product. Then you are rubbishing him. Doesn't suit you, right?
Yeah.
So you should go with facts and figures. You should go with certain clear idea ki what kind of reliability support you are talking of. You want more spares. You want financial support. You want this. When you go and give this kind of this thing, the negotiations become much more productive. But I mean, you learn as you get along.
But then, see, I mean, your major career has you have spent with Air India during when it was a government-backed airlines, and I'm sure the OEM discussions must be happening at the bureaucracy level as well. And bureaucracy ka I mean, it's, I don't want to use very harsh words, but how does those negotiations look like? And in your
so let's split this into two things.
right,
OEM is a big company, as I said,
right.
and he's got a lot of things. And then at certain level, ownership level, whether it is governmental or private ownership, certain commercial discussions happen at certain level, which is beyond engineering.
Right.
I mean, it has to happen. I mean, in my opinion, that is the correct way also. Whether it is done by a bureaucrat or whether it is done by a group head of a conglomerate or whatever the promoter, it has to happen.
Right.
I think the knack here is to separate commercial and technical discussion.
Okay.
Commercial discussions have happened, good or bad, whatever. You got a fleet which you have inherited. The fleet is with you. The fleet is showing this issue. And these are the technical things which are getting associated and getting out of control.
Right.
That's why you are there. Let's focus on this. Let's get this resolved. That should be the approach.
Right.
What I inherited, I have to accept, good or bad.
Right. So, you have a perspective for 40 years. What do you think is the single most thing that's going wrong with OEM negotiations, and what can be fixed?
I think most of the time it's the ego clash.
Okay.
Both kind of stick to their very they are very adamant on their stand, showing no flexibility or understanding of the problem. Look, OEM doesn't want to put you in a ditch. Neither you want to put OEM into the ditch, because then you will not get the support.
True.
Those boundaries are very clear.
Right.
Now, within that boundary, there are difference of opinion. There could be shouting match. There could be a lot of huff and puff. But the end of the day is what? If you have to move beyond something and get something productive, you have to meet at a common ground. Look, these are the supports. I need this. I need this. I need this. And the OEM also has to understand that. Look, India may be a harsh environment condition or country. But doesn't mean you are selling the aircraft here, right? They have to support, good or bad. So give enhanced support.
Right. Warranty claims. Something gets promised on paper versus what at the time of executing that you go calling for it. Ki bhai, this thing was in warranty. I want this thing checked or replaced, whatever it is. What happens on paper and what happens on ground? Are those two different realities, or they are enforced?
So I think what you are hinting at is warranty versus reliability.
Yeah.
So I think there are two different things. Warranty is something which is written on a piece of paper. That look, if this condition happens, the OEM will fix in this way, that he will for so many hours or something, he'll give you a free replacement. After that, he'll give a free repair. After that, he will give a support, blah, blah, blah. But reliability is how reliable that equipment is in your operation. These are two different things.
Very true.
If the leadership of a company is focusing only on warranty and not focusing on reliability, they are making a fundamental mistake. Because getting support is not going to put your operation back. It's in your medical field. I mean, if you have a state-of-the-art machine, warranty obligations are getting fulfilled. But the machine conks off every second day.
Not happening.
I mean, how does it help you? Even if you are getting a warranty support, how does it help you? Your business is at stake. Similarly here, I mean, if you are not getting a proper reliable product, it has happened. There are certain a case of hydraulic pump, for example. It was failing repeatedly. I mean, no, it was not that OEM was not giving the warranty support. But in spite of warranty support, how does it help? I mean, if you have to replace 20 pumps, 30 pumps every few months, across the fleet, your reliability goes for a 6. You're getting aircraft are getting stranded somewhere.
Obviously.
So a whole lot of things. The emphasis should be on reliability, in my opinion. Warranty is an important aspect. The focus should be on reliability.
So, I'm going to ask you certain uncomfortable questions now.
Right.
Do you think Indian aviation is safe, or is it safe enough?
As I said, whether you fly Indian registered aircraft or a foreign registered aircraft, you are in the safest mode of transport that
understood.
That is there. Now, I would say we are safe enough. We are safe to the extent we are safe, 100% safe, no doubt about it. I explained that Dunning-Kruger effect, that gets little more highlighted. Say simple flight turned around, for example. It's a simple thing. I mean, a pilot is not able to sight the runway, goes around and lands. But when it comes in the paper, this flight had a go around,
right,
it creates a different psychology.
Right, true.
You tend to have a very, slanted perception of the whole thing. So let's put that aside. Let's consider aviation as the safest mode of transport today. I mean, when you're talking India, you should also consider what is the safety record of Indian Railways, for example.
Yes, true.
So,
so when we see, when something goes wrong, there is a lot of media attention. The regulators want somebody to blame, but the engineers know that the problem is systemic. So within whatever, how do you conquer that noise that is coming from outside, and you engineers are able to work off in a systemic way in the back end to fix the problem?
So I would say that leadership, rather crisis management, is more of leadership issue rather than engineering issue.
Okay.
Engineers can fix the problem, and there's no third way in engineering. It's a right way, or it's fixing the problem, the engineering problem, till it is fixed.
Right.
There is no third way. But leadership has to manage so many other things. They have to manage the media pressure. They have to manage so many things, and their job is to isolate the engineer. Let them perform the job. They are performing the job. Let them do it. You have to manage the other thing. You have to manage the noise. You have to manage the clutter. You have to manage the media. You have to manage the afraid passengers.
True.
So the leadership assumes that role. And a crisis, in my opinion, the crisis management rarely fails because of engineering. It fails because of bad leadership at certain levels.
You have seen the change in Air India from a government-backed airlines to a completely. Were you there when the privatization of Air India happened, or did you retire?
No, I was not there for privatization, but I worked in a private company also separately.
Yeah. So what differences do you see in working in a government sector versus the private sector? Your take.
So, see, I didn't work under the new management of Air India, so I wouldn't go into that. Basically, I would say my transition from a public sector to a low-cost airline. What I felt was in low-cost airline, the decision-making structure is more nimble.
Okay.
It's more responsive. The unit being smaller, it's more cohesive. Whereas in a public sector, it becomes very, vertical dominated structure. Like, the silos are very compartmentalized.
But I forgot. I wanted to talk to you about this $200 million project of MIHAN MRO you were trying for years. I think it did not take off in your leadership. You were the lead person. But it is taking off now, but very slow.
So there's a joke I call on myself. So I consider myself as a modern day Shah Jahan who never got to see Taj Mahal. But it's one of those things.
Okay.
It was 95% complete when I retired.
Okay.
And then it got completed subsequently. But then what happened was, meanwhile, Air India was privatized. So then the question of it ended up in complications in the sense the IP issues came. Who should own the IP rights? Now the airline is split. Then financially, Air India was not in the best of the condition, before privatization. So a whole lot of financial IP issues came. The project is on. I mean, I am not current with the project status, but I believe the facility is up and running. I don't know the volumes. I don't know the throughput, but functionally, it is functional.
Yeah, but I was reading a report that I think we have the 4th largest aviation in the world in terms of traffic. But more than 50% of our fleet goes out for servicing to MROs. And I read a report that by 2030, we are trying to capture that 50% of market of MROs in India itself. Are we on target? What are we doing right? What are we doing wrong?
I read the right signals at this stage.
Okay.
I think way back, if I remember right, when I was in that position, way back in 2010, in one of the budget speeches, MRO sector was declared as a sunrise sector.
Okay.
And then pretty much nothing happened for the next 10-15 years. But now, when I see this kind of investments coming, 2-3 MROs coming up in airframe space, then engine MRO coming up in Hyderabad, people are talking of, manufacturing aviation components. So I see a lot of positivity here. And I think that decision makers have realized that if India has to grow, you can't be sending every aircraft, every component, every engine out for repair. You need a strong MRO ecosystem in India. So I love the efforts. I think it should have been done earlier so that we could have reaped the benefits. Not only reaped the benefits, see what happens is, look at Lufthansa model. Lufthansa fleet is not that great, but their MRO throughput caters to many more clients than Lufthansa.
Okay.
It's a business model for them. It's a strategic business unit generating revenues and profit for Lufthansa. Such things should happen in India, and
right.
I hope, someday or other MRO becomes a profitable
Well, that
sector.
brought another question to my head. Why can't we start OEM manufacturing in India for components?
I think OEM manufacturing to some extent is happening. See, it's a big chain.
Yeah.
It has to go through several processes of accreditation, approvals and all. And then it's a cutthroat competition. Like we are thinking, the whole lot of other countries also
Right,
thinking
obviously,
of that.
yeah.
And it's all said and done, it's a duopoly between Boeing and Airbus. They also have their own set of preferences and whatever. Every company would like their vendor systems to be as close to them as possible. So many things are there. But I think, as I see now, there are a lot of companies entering into the manufacturing space, and I feel optimistic that slowly it will improve.
So, this is one question I forgot. Airbus versus Boeing, what do you think?
It's a duopoly. Aircraft wise, both are good.
Right. From a pure engineering perspective.
By engineering perspective, I feel certain systems of Airbus, they seem more advanced to me, especially in avionics, than Boeing. Boeing tends to adopt a little conservative approach, when it comes to kind of rather the freedom which it gives to the pilot versus freedom Airbus gives to the pilot. Whole lot of different philosophies go there. For example, there is a yoke in Boeing. Airbus doesn't have a yoke; it has got a side stick.
Right.
So when this change came, everybody thought, "Oh my God, it's such a big change." I mean, it's like taking the heart away from the human body. How can you fly an aircraft when there is no yoke? But today there are certain people who swear by the side stick. They say it is so ergonomically good, it keeps the other hand free. So a whole lot of things, I wouldn't say this is good or this is bad, but personally I believe avionics wise or the flight envelope they call it flight envelope. Airbus has a very tight flight envelopes and a very kind of a very tight laws, I would say. The aircraft goes by certain laws, the normal law and alternate laws. Those logics and this, I tend to believe, are a little superior for Airbus. That doesn't mean Boeing is bad. It has got a different framework of ideology and it's going as per that.
Right.
But personally, as a technical person, I prefer Airbus.
There was something happened in US Senate where the Boeing CEO was pulled up for a lot of fallacies and lacunas. I think 6 to 8 months back this was in the report. I keep forgetting what that was. But even something went out.
So let's broaden this question.
Yeah.
Let's make it a debate versus of accountability.
Yeah.
So when you talk of accountability, I believe at ground level, I mean at engineer level, right up to the COO level, there is 110% accountability because each one is signing, doing the task and signing. So there is no question of accountability not being there. At CEO level also, there is an accountability, but then you do get glimpses of little softened accountability. Like for example, the recent meltdown of a network in India. The CEO was made to exit, but little in a softer way.
You're right.
Similarly, the Boeing, what you referred, he exited, but with all the compensation protected.
Right.
So it somehow feels that the end result is not comparable to the kind of thing which happened. It seems little softened. So at CEO level, I believe there is accountability. So what I said is at ground level, 100%, working level 100%, COO level 100%, CEO level also 100%, not 100%. It is there, but glimpses of softness you see somewhere. Where I think, and this is my opinion, where I think it kind of blurs, and this is not only for aviation, it is across the sector, is at level beyond CEO.
Okay.
Look at the subprime crisis. So many decades.
2008.
Do you know anybody who has been held accountable for this?
No.
How can it be? I mean,
it's not possible.
In the whole, not only one country, the entire world economy collapsed.
Yeah, very true.
Do you know anybody being held accountable?
Absolutely not. Even.
So there I think it fades out. Look at the number of airports which came in India. 10 aircraft, 10 airports I believe somewhere. And no flights have operated there for last 3 years.
I know.
This is where I think accountability fades.
Yeah. So you've in your tenure you've dealt with bureaucrats, politicians. I'm sure you must have had meetings with people at a very powerful level. How does those? I mean, what is the energy happening in that room? What are the type of conversations you're having at that level of upper hierarchy levels?
One thing which I was struck anywhere, whether it is bureaucratic level or whether it is at the promoter level, whether it is at a CEO level or board level, I think you are dealing with extremely intelligent people. No two ways about it.
Correct.
I mean, now each style is different. Some are soft, some are absolutely harsh, some are shouting at the top of the voice. But bottom line is, they are extremely focused, they are extremely sharp. So don't ever get into those kind of rooms with an unprepared list of things.
Okay.
That is a surest recipe to get ripped off. I mean, they'll rip you. I mean, a small, I've attended a meeting where a small Excel file error that was played out so big that that guy lost his total confidence. He has done a good job. He was basically a good man doing a good job, but he overlooked a small error. So when you're going to that level, you should be more prepared. You should rehearse. I mean, you should not leave it. And the worst thing people do is to give this job to a junior person, and without even having a second glance at it, you go and represent that.
Right.
I mean, this is a recipe of disaster. I mean, you will be exposed thoroughly if you do that, because they are going to ask you pointed questions. And if you are not prepared, you are in for trouble.
I always think that people have this impression about CEOs and CFOs that they are not doing anything and they are having very fat salaries. But I've often read a few books where the kind of information they absorb, the capacity to absorb and retain at that level is that's on a very different level that they do.
Yes,
and they have excellent recalls, I've seen.
Absolutely, and another thing is I have seen in my case,
Yeah.
I mean, I've seen it not once, so many times. They come out with a perspective. You have prepared this project, you have prepared this report, you have spent midnight oil into this. But that perspective which they suddenly bring out in that 5-minute meeting, you have never thought of.
Right.
So they are sitting there not because of they are somebody. They are sitting for a reason.
Yeah.
And you have to acknowledge that fact.
Obviously. Before I let you go, I'm going to ask you some rapid fire questions, okay? So, one airline that runs the tightest technical operations in India right now.
I think Indigo by and large.
Okay. Boeing or Airbus, if you had to pick one for the next 20 years?
Airbus.
The most underrated airport in India from a pure aviation infrastructure standpoint.
Underrated.
Yeah.
I think Chennai is underrated.
Oh,
Chennai
why so?
Chennai is underrated. I think Chennai should handle much more flights, many more flights.
Okay. The biggest myth that non-engineers believe about aircraft safety.
Believing in social media, giving exaggerated importance to something you don't understand.
From a pure engineering perspective, what happens when you board a flight? What is happening in your head?
I tend to notice small things.
Right.
For example, I notice a frayed carpet, the
Right.
center rail carpet. I wonder why they can't change it and keep it spick and span.
Right.
Because the first impression one sees is the carpet, anywhere, flooring carpet. If that is swanky, the whole impression of the airline changes. So
Right.
I wonder the small things why they don't take care.
One person in Indian aircraft industry who deserves more credit than they received.
One person.
Yeah.
I don't know. It's difficult to say that. I think there are a lot of engineering people who did a lot of engineering. I don't know. It's very difficult for me. I pass that question. Sorry.
There's one thing that you wish every Indian passenger knew about.
Think aircraft as your personal thing. I mean, don't think it is meant for single operation. If you hang against that baggage rack, you're going to suffer it in the next flight because that is not going to help you. So treat it with care, treat it with respect.
Okay. Thank you for this. But before, again, one last question. Your advice to future engineers who are thinking about getting into aviation industry.
Okay. I will... okay, let's broaden this.
Yeah.
Let's say what is my advice to the young generation who is now aspiring to assume good leaders, good engineers. So I would talk on 2-3 things. I have 2-3 minutes to talk.
Go for it.
Yeah. Okay. Now, you should develop certain inner qualities. First and foremost, you should have belief in yourself.
Mm-hmm.
If you don't have belief, and I'm not saying under overconfidence, you should have a very quiet belief that you can handle situation. If you don't have that belief, then you can never become a good engineer or a good leader. Then you should not imitate blindly others. I mean, Amitabh Bachchan is superb, he is good. Einstein was superb. But you can't be another Einstein, you
Sure.
can't be another Amitabh Bachchan. You try to be as good as them. I have no quarrels. But you try to have your own originality, know your strengths and weaknesses, and model yourself as you, not as somebody else. Third thing, you should have passion for what you're doing. And that includes hard work. जैसे ऊपर ऊपर काम करके कोई भी लीडर और अच्छा इंजीनियर नहीं बन सकता है. Putty, Birla Putty or Plaster of Paris can do the job, but it can't make you structurally strong.
Right.
These are the 3 inner qualities. Once you have these 3 inner qualities, you should understand that leadership rests on 3 pillars: purpose, composure, and adaptability. And this is not a management class, so I'm not going to dwell on each thing. I'll give you 3 very good examples.
Sure.
Take the example of Captain Sully Sullenberger. You know, the New York crash landing, or rather landing, ditching. Sully, Captain Sully.
Yeah, yeah.
So he was coming in to land at New York. He lost both the engines.
Yeah.
He knew he will never make it to New York.
Yeah.
So his purpose was very clear. He wanted to save lives. He remained calm. Composure was very
Landed in the
clear.
Hudson River.
He ditched in Hudson River and ditched it such that he was very close to the the firefighters and the relief people.
Right.
So even in spite of the river was freezing at that time. In spite of that, nobody died.
Yeah.
So that is excellent example of purpose, composure, and adaptability. You have to adapt. He adapted. See, no textbook taught him to ditch the aircraft in Hudson River. Second is your medical example. There was a serial called MASH in good old time.
Right.
It was probably before your time. This is a set of US Army doctors who are operating from camps.
Right.
It's against, I think, in Korean War or something. But they are able to give medical treatment which is comparable to best in the world.
Oh.
They were being compared to the best of the hospitals in Boston and New York.
Lovely.
Now you imagine, bombs are flying, but they are composure. Huh? Whatever they could lay hands on, they picked up. So some ammunition tube or something served as an oxygen pipe. They adapted. And they remained with a purpose. I will give the best of medical facility under this condition also.
Yeah, that's
so again, good example. I always quote this to all my youngsters. Baba, this is a great example of, in the war field. You are giving a medical facility which is comparable to a hospital in Boston and New York. Imagine, which is having all kinds of things. The third is the Thai cave rescue. 12 children. They went underground and then got trapped.
I know.
And now the leadership was very clear. They had no expertise in caves. They were no cave experts. But what they did, they adapted to the situation. They called in the best of the cave geologists, the best of the trauma doctors, the best of the, even the meditation experts, the cave drivers, geologists. They formed a team, and each person was given the lead responsibility was given to the person of that particular. If it was somebody was going inside the cave, the geologist was leading the way. If a medical trauma guy was needed, medical trauma was given the lead. And they managed to rescue the entire set of, it's a miracle. It was the oxygen supply was depleting, the children were dying of hunger, caves were getting flooded, the water levels were rising, but they still managed to rescue. So this is again a great example of composure, purpose, and adaptability. So always remember, these three things and your qualities will make you a great leader.
Oh, nice. Thank you so much. I really enjoyed this conversation. Any advice for me?
Continue with your channel. Good work. Continue to cover various, variety of topics.
Thank you.
You make it interesting, and hope I wish you all the best.
Thank you so much.